Okay, so here's the setup for a demonstration of the magnetohydrodynamic effect. Here we have a power amplifier. It is hooked up via this hookup wire to a piece of strut channel here. We've got two electrodes in there that are about 8 inches long. They're copper. They are epoxied to the sides there. Got a scale on the bottom so we can judge the speed of the flow going through here. It goes 0 to 25 centimeters. And the water in here is salt water, and it's about as much salt as water will dissolve. Okay, so first demonstration here, we've got our power supply set to 1 amp. Got the magnet in place. Once again, we got the north pole down, so the field should be going down. The current's coming towards us. And we can see here some of the chemical effects that are going on. We've got some gas production going on there. And you can see this stream of yellow stained water coming out from our negative electrode, which means the electrode is corroding. That is one of the problems with this technology. Is you need noble electrodes, something like platinum, very expensive. Regular copper will just erode away with the high currents. Okay, so I've put this foam in here so that we can change the distance and change the magnetic field that's going to be experienced by the current coming across the channel. So this is our far and weaker magnetic field setup. Once again, we've got 1 amp. So let's see what kind of flow we're getting. Okay, there it goes. It's in the flow. So now on the other side. Okay. So this is about the weakest cross product we're going to have. We've got 1 amp and the magnet far away. So that was about 2.8 centimeters per second. I've actually already run this experiment, so I already have the numbers. Alright, let's crank the current up. Let's see what happens when we go to 5 amps. Okay, so we have the same cross product, force is to the right, except our I is now stronger. Take a look at it. You see our corrosion products are streaming out of there faster than they were before. So let's time it. Drop our piece of test foam in here. There it goes. Alright, so that was about 7.9 centimeters per second, whereas the first setup with 1 amp was 2.8, so that's sped up quite a bit. Okay, so let's manipulate the terms of the cross product a little bit. This setup we have 1 amp again, so we're starting with our lower current. As you see, this time I've removed the foam that's holding the magnet up, so our magnetic source is much closer to the current carrying the water down in the channel. Once again, that's our cross product. Current's coming towards us, magnetic field's down, so the force should still be to our right. So let's time it. We'll drop our piece of test foam in here. There it goes. They're going pretty quick. This one is about 6.3 centimeters per second. Now, let's go for our maximum value of the force via the cross product. Let's increase the current to 5 amps again. Alright. Once again. Same current direction, same magnetic direction. See, one got caught in there. Except now both values, the current and the magnetic field, are maximized. Let's test it. It was really going. So that is about 15.2 centimeters per second. Okay, now that we've added the magnitudes of our cross product, let's change the direction. So now I've flipped the magnet over, so the north pole is facing up. So our magnetic field in the green there is coming out of the channel. Current's still coming across towards us, so if you do IL cross B, the force should be to the left. Let's turn our current on. See that corrosion product streaming out to the left there. Let's test it out. Still moving about the same speed, which was about 15, 16 centimeters per second, except it's going to the left now since we've reversed the magnetic field.